So I want to talk a few minutes about a topic which has some deeply technical aspects, which I've written about in some papers over the last couple of years. But we're going to keep it at a very hand-wavy level here because I just want to take up 10, 15 minutes or something to not run over time too much. What I want to talk about is aspects of motivation for AGI systems. And this is one of the things I learned from Josha Bach's work on his thesis and engaging with Josha over the years, is just how important motivation is as an aspect for AGI. I mean, of course, it's certainly not the only thing. I mean, like my dog may be motivated to, get the food that's in the refrigerator. He just can't do it. He's too stupid to figure out how to do it. There's a lock. He can't get the key and open the lock to get it right. So it's not everything, but it's incredibly important. And as an educator, you can see that all the time. Like within fairly wide range, I would bet on a less capable student who's highly motivated over a really smart student who doesn't give a crap. There's limits, but the limits are broader than we often take for granted, right? And so I've mentioned how representation is very important and how people are increasingly seeing that we need to think somehow about getting to abstract symbolic representation, and how having the right learning mechanism is important. And if you have something like backprop with the wrong learning mechanism, it doesn't matter if you have the right architecture. So those are important, but motivation is also extremely important. And I think, commercial machine learning systems have a very simplistic excuse for motivation, right? They don't really have it. The motivation they have is like, let's minimize error on some data set, which is too crude a motivation to lead to anything resembling a human-like general intelligence. But the type of motivation that's generally considered in the mainstream AI field now is basically drawn from the reinforcement learning field. It's like reward maximization, maximize expected reward over some time scale or some weighted average of time scales. And I think that's also a very, very crude excuse for a model of motivation. And in the AI ethics field, then, I mean, people have spent a lot of time and hand-wringing about, well, if a system is just maximizing expected reward, well, won't it like wirehead its reward function and just stimulate its reward center forever to maximize expected reward? And you can do a lot of somersaults over how do we avoid something like this from happening. Or say you tell something to make people happy, and you tell your AGI system it gets more reward if it's making people happy. But how does it know what happiness means? If it means people are smiling a lot, okay, well then it can just like surgically modify people to be smiling all the time, right? So any definition you give of happiness, a superhuman AGI could just hack away to maximize that definition without doing what we meant by human happiness, right? So there's been a lot of agonizing about the ethics of systems that maximize expected reward and how do you define the right reward function. My own view has been that maximizing expected reward is just a really sort of dumbass way to think about the motivation for an AGI system in the first place. Not that it plays no role. I mean, yeah, there's dopamine systems in the brain that approximate temporal difference learning, and they're trying to maximize expected reward. And there are times in each of our lives where we're trying to like make the most money we can, or get the most girlfriends we can, or get the biggest house, or we do try to maximize expected reward at some periods in our lives. But I mean, we adopt different rewards at different points in our lives for different reasons. And it's not really that simplistic. I mean, people are martyring themselves for causes that they believe in, right? There's a great deal of complexity to the sense in which humans are maximizing expected reward, to the extent that I'm not sure it's the right paradigm to be starting with. I mean, one can just say, well, the hell with thinking about reward. The intelligent systems like humans or AGIs are complex self-organizing systems, and goals and rewards are just among the things that pop out of the complex self-organization for a while. then they go away, and other rewards and goals pop out of the complex self-organization. And that's a perfectly valid way to look at it, but I'm not sure it's the maximally informative way to look at it. I mean, I think the notion of a persistent set of motivations in the cognitive system, I think, is interesting, although not complete. There is an amount of complex self-organization that's not really motivated. It's just happening, like in a chemical soup or something. But I think the best ways to think about motivation in AGI systems are a little subtler than expected reward. So I want to introduce some somewhat new ideas here, drawn from the notion of open-ended intelligence and some ideas from paraconsistent logic as related to goals, motivations, and rewards. So click. Let me start with a question that all of us in this room have probably thought about a lot. I'm not going to go through in much detail, but what is intelligence in the first place? And intelligence is very badly defined. I mean, when I was working in the late 90s and early aughts with Shane Legg, who was in early 20s and later went on to co-found Google DeepMind, at that point in his life, Shane was convinced, like, if we could just rigorously define intelligence, then the path to AGI would be really easy. The whole problem is intelligence is badly defined. And he was trying to define what he called cybernance then, to get rid of the messy word of intelligence. And I disagree with him fundamentally. I was like, well, you know, life isn't well defined. You can still do synthetic biology. Beauty isn't well defined. You can still make beautiful art. Like, the fact that this is a fuzzy word just means it's a fuzzy word for describing what we're doing. We can still build, okay, just let's build a system that can graduate from MIT doing exactly what a human does, and don't call it an intelligence, call it a human emulator, right? Or let's build a system that can solve as many computable problems as possible, call it a problem solver. Like, I don't care about the word intelligence. It's just a messy natural language term, right? And I think after writing a PhD thesis in which he came up with a rigorous mathematical definition of intelligence, which is not bad, but has some profound flaws to it, he seems to have changed his mind, put it aside, and just gone on to try to build systems doing cool stuff that are very loosely connected to his own definition of intelligence. So I think he sort of came around to my perspective on that. But even though I don't think you really need to rigorously define intelligence to make progress in AGI, it's still an interesting intellectual exercise to sort of beef up your mind for making progress. And so we can look at a few different ways to gauge intelligence. I mean, obviously in psychology, the G factor, IQ, was intended to measure general intelligence. It's sort of pretty much a weighted average of how well you do across intelligent tasks in a bunch of different areas. It's not a terrible measure. I mean, it's not a great measure either. It's very culturally biased. I mean, like, the IQ tests we have now are very visual oriented. I often thought if you replaced all the vision problems in IQ tests with musical and rhythmic problems, suddenly Africans would come out having a much higher IQ than everyone else, just because culturally they're always doing music and less visual stuff, right? So there's severe flaws. On the other hand, there's not much doubt, if I talk to a random person with IQ 160 or a random person with IQ 60, like, the test results are going to accord with my intuitive understanding of how good they are at solving most sorts of problems. Like, there's some meaning there. On the other hand, it's clearly highly overfit to human beings, right? Because there's clearly, you could make a narrow AI system do well on an IQ test, but that system has no general intelligence. It's just been trained on a shitload of IQ test answers, right? So it's definitely very overfit to people. You can't give an IQ test to a dolphin, right? Dolphins may be almost as intelligent as us, but I mean, you can't expect them to solve these exact puzzles. You have to give them a sonar problem instead of a vision problem, for one thing. There's a theory of multiple intelligences. Very interesting. I mean, you could look at IQ as a sort of weighted average over all these multiple intelligences of math, vision, language, space, time, and so forth. And more interesting, just for qualitatively evaluating your AGI system to see how it does across all these different dimensions of human-like intelligence. Still, I mean, pretty overfit to human beings, and doesn't make your job easier engaging and comparing things because you're going to multiple dimensions. Now, what Shane Legg came up with, based largely on the prior work of his PhD supervisor, Marcus Hutter, who's, by the way, the co-founder of the AGI conference series, although he's not here this year. What he came up with is basically measuring general intelligence as a weighted average of the ability to achieve a computable reward function in a computable environment, where you weight the average by weighting simpler reward functions in environments more. And then how do you measure simplicity? Well, you assume some simplicity of a reward function environment could be, for example, the size of the smallest program for computing that reward function or environments. You're going to algorithm complexity, algorithmic information theory. And that's a reasonably interesting definition. I mean, one issue with it is that human beings are incredibly retarded by this measure. Like, we're very bad at achieving arbitrary reward functions in arbitrary environments. Right? I'm very bad at like playing 87-dimensional chess or something. Right. So I mean, how do you really define an arbitrary reward function? I'm even bad at understanding, you know, what other people are thinking, and that's a problem I confront all day, every day. So, I mean, to come up with a simplicity measure under which humans are good at achieving simple reward functions in simple environments, you really have to hack that simplicity measure just to weight exactly the only things that people are good at, which then sort of defeats the purpose. Because then if you had a dolphin, to make dolphins good at achieving arbitrary reward functions, and you'd have to hack the weighting function of rewards and environments for those things that dolphins are good at. I mean, there's a lot of other weird issues there in terms of it depends on the simplicity measure. In theory, as rewards and environments get infinitely complex, it doesn't matter because of bisimulation among different Turing machines. But our practical world is not infinite, right? So it's not clear if in everyday senses you really get that universality, or it's highly dependent on how you're weighting things. There's also a philosophy problem here, in that we're still stuck in expected reward maximization and assuming that what AIs are after is expected reward maximization, which I think is a sort of like brutal degradation of what it means to be a vibrant living system, really. So Wang, in a definition I eventually came to realize is profoundly Chinese in a way, after living in China for 10 years. Wang defines intelligence as the ability to adapt to unpredictable situations under limited resources. And I mean, that's how the Chinese Empire survived for 5,000 years, right? I mean, there's a lot of wisdom baked in it. I don't mean to minimize it by saying it has some cultural resonance, but I do think that the idea that life is about getting more reward than all the comparators has some Americanness about it somehow. More, I got more than everybody else faster, right? So there is some cultural resonance baked into these things, although of course there's also deep intellectual thinking going beyond all that. But the idea that you want to adapt to unpredictable situations under limited resources is quite deep in a number of ways, because if the situation is unpredictable, that means it's going beyond your history. So to adapt to it, you have to generalize, right? By definition, you're going to something you couldn't have predicted. So if you couldn't have predicted it, then you have to generalize it to it somehow. And there's almost a paradox baked in there when you think about it, because if it's really unpredictable to you, then how the hell can you generalize to it? Being able to generalize to it in a way is implicitly being able to predict it. So there's almost a contradiction based in there, depending how you define the terms. And baking in under limited resources really constrains the sort of systems you could make. It means you can't have a giant lookup table, right? And which basically means you can have a deep neural network, which is sort of a big weighted hash table in a way. It also means you can't have an AIXI or other Marcus Hutter type system that does a search through the space of all computer programs or something. It means limited resources sort of means you have to have something resembling a cognitive architecture, because you have to juggle with limitations of space, time, and energy. So I mean, I think that's a very wise and interesting way to look at it, and ties in well with the final definition, which is the one I'm going to work with for the next few minutes, which comes from Weaver, aka David Weinbaum's PhD thesis on open-ended intelligence from the Free University of Brussels from a few years ago. So Weaver, in his thesis, is trying to synthesize the theory of complex self-organizing systems with ideas from continental philosophy and Deleuze and all that. And he's looking at an intelligent system as a complex self-organizing system, which has two primary sort of drives or directionalities guiding its movement. One is individuation, the other is self-transcendence. And these are both sort of things drawn from continental philosophy, but they also can be clearly grounded in evolutionary biology and so on. I mean, individuation is maintaining the boundaries around the system as a distinct system, right? It's really just a fancy way of saying like survive as a system with the continuous thread of being over time. Self-transcendence is the drive to become something fundamentally different than what you are and going beyond what you were before. And so these two things together, again, you have a sort of paradox baked in here, just as there's a paradox baked into being able to adapt to what you can't predict, right? And the view of a intelligence as an open-ended system that needs to maintain its boundaries over time while transcending everything it was and becoming something new. I mean, this is what evolution has done, right? And this is what a human child does as they grow and develop from infancy into adulthood. And you could try to boil that down to a reward function, but in the end, one of the points Weaver makes is you really don't succeed. Like the reward function you're maximizing in one stage of your development is not the one you're maximizing in the other stage of your development. And we see this in the human life cycle. Like the reward functions my 4-year-old son is working toward, they're not the same as his 1-year-old sister. They're not the same as I'll be working toward as a teenager. They're not the same as what I'm working toward now, right? I mean, as a human develops, development being different than learning in psychological lingo, but as a human develops, the reward functions they're seeking on a temporary basis really do change, right? And that's important to our general intelligence over our lifetime. Let's click. No, you're a bad clicker, Haley. Come on. Click. Yeah. So I want to just talk for a few minutes about how I've been thinking about open-ended intelligence in terms of practical goal systems for the OpenCog system. And the full mathematical story here is more than I have time to go through. So I'm just going to wave my hands around, but I had a paper called Paraconsistent Foundations from early 2021, which reviewed constructible duality logic and how you intersect paraconsistent logic with uncertain logic. Then I had a blog post on my Substack blog, which is called Paraconsistent Motivations, where I sort of go over this stuff in a little bit more detail. I'll write a full-fledged paper on it at some point. But paraconsistent logic is a branch of formal logic that handles contradictions. So you can, in classical propositional logic, if you have one contradiction, like, my girlfriend loves me and she doesn't love me, right? Then you could derive the moon is great, made of green cheese, or the Pope is a donkey, or whatever it is. Like one contradiction infects your whole logic system, and then everything is meaningless because everything can be derived, right? In a paraconsistent logic, you can have a contradiction, then you derive limited number of contradictions from it, but you can't derive all possible contradictions from it. So you have limited set of rules, mostly for manipulating negation. You have a limited set of logic rules that doesn't make a single contradiction fatal. It's pretty clear that human reasoning is like that, commonsensically. Like we all contradict ourselves in some ways. It's like Walt Whitman's quote, I contradict myself. Very well, then I contradict myself. I'm large. I contain multitudes, right? So, I mean, we're all like that. We're massively parallel systems with all sorts of contradictions in them. And a system like OpenCog or NARS can contain contradictions in it, and it doesn't pollute the whole knowledge base, right? Quite different than a Bayesian network or a Markov logic network. They can't have a single contradiction, or it will pollute the whole knowledge base. But how do you manage that contradiction? Well, there's multiple ways. I mean, NARS has its own way of managing contradictions. Paraconsistent logic embraces it like full on and says, okay, well, for example, in one version of paraconsistent logic, for example, constructible duality logic, you can say, I'm just going to have 4 different truth values, not just true, false. Something's going to be true, something can be false. Some can be both true and false. Some can be neither true nor false. And people have used this to model aspects of Taoist philosophy with the yin yang and so forth. Because in traditional Chinese and Indian philosophy, if you look in philosophy of Vedanta or of Tao I Ching, there's loads of both true and false, or neither true nor false. I mean, but you could look at it in a very nitty-gritty way in terms of evidence counting too. I mean, there's some things I have so little evidence about. For me, it's neither true nor false. I have no idea. There's some things I just have contradictory evidence. And I don't want to throw out any of that contradictory evidence. At the moment, I'm going to keep the contradictory evidence and just say, well, there's ways in which this is true. There's ways in which this is false. Maybe it gets resolved later. Maybe it never does get resolved, right? So this sort of paraconsistent logic, it's one way to handle reasoning in a very uncertain world where things are contradictory and confusing. It's a funny word because these systems are consistent in some senses of mathematical logic, but they're inconsistent in other senses, and it gets deep and thorny. But what struck me last year was this was an interesting way to think about conflicting motivations. Click. All right, you're adapting to unpredictable conditions. So there's also interesting relations between paraconsistent logic and time. And there's a beautiful little book called Laws of Form that I discovered in the 80s, which sort of gives a novel foundation for propositional and Boolean logic, and also for the logic of paradox. It's sort of at the border of philosophy and math, but quite a beautiful little book. But one thing he does there is he looks at paradoxes like x equals not x. And he just points out you can spell that over time as a series. Like if you have x equals not x, well, that sort of corresponds with a divergent series of true, comma, false, comma, true, comma, false, comma, true, comma, false, comma, true, comma, false, or vice versa. You can look at two different iterations that you get that way, and you can play with that. You can take paraconsistent systems of paraconsistent logic expression, use them to generate time series, and this I think has some relation to motivation and cognitive systems. For what I'll say in a reason I'll say in a moment. Click. So parody of how to apply this to ethics, which is not what I'm seriously proposing, but sort of gives you an idea. You could say, okay, some things are good, some things are bad, some things are both good and bad, some things are neither good nor bad. And so we're back to Nietzsche here with beyond good and evil, right? So this is fundamentally stupid because good and bad don't have too much fundamental meaning, but it sort of illustrates the way that paraconsistency could apply in an ethics domain. Next, click. So if we want to take this more seriously, we could look at how would you make a goal system for an open-ended intelligence? And you could look at, okay, goal of the system is to individuate and to self-transcend. And of course, an issue there is often what you would want to do to individuate, to maintain your boundaries, is opposed to what you need to do to self-transcend, which is to become something radically different and go beyond what came before. Like, these are often just plain contradictory goals. And this is like what all of us go through in our teenage years, right? We need to grow into something different than we were before, but we still want to be ourselves. And it is just plain a contradiction, and we wrestle with that contradiction without it always making us believe the moon is made of green cheese, right? And if you want a more thorough motivational system, okay, we're not purely self-focused. We also care about other systems around us, and we want individuation and self-transcendence for the other systems that we're dealing with also. And this would be, to me, the kernel of a motivational system for an open-ended intelligence, which is different than maximize expected reward over some time scale. And you can't really project it into maximize expected reward without being very contorted and coming up with a reward function that's very, very, very screwy. So this, I think one can actually boil this down into concrete measurable things inside an AI system without too much more pain and suffering than you do for expected reward. It ties much less easily into commercially profitable machine learning systems, all right? Because maximize expected reward ties very well into like increase clicks per minute or something on my website, or increase money coming into my company, because you have companies that are trying to maximize their own expected reward, because that's how companies work, right? So this is perfectly viable to build software for, but it maps into the overall context in which AI is being developed differently than expected reward maximization. Click. So yeah, if you can boil this into more comprehensible values, like I've talked in previous writings about joy, growth, and choice as sort of qualitative values that cut across cultures and multiple minds should respect. I mean, the self-transcension aspect of open-ended intelligence is about growing, and individuation is about, I mean, joy and happiness are in large part about increasing sense of unity, and this often comes along with individuation. And of course, choice is establishing oneself as an individual who can make decisions. So I think these system theoretic values tie in with other more psychology-oriented values in ways that could be unraveled more. Click. But the contradiction here, of course, is as you reify your boundaries as an individual, in some ways you're inhibiting yourself from self-transforming. And on the other hand, as you radically transform yourself and plunge into the great unknown, there's a large risk that you destroy what you were before and lose your boundaries as an individual. And I mean, embracing this paradox is something we each have to do multiple times over our human lives, often at great personal cost in terms of suffering and worry and so forth. And this is tied in, I think, with the process of revising our reward function, because to the extent to which we're pursuing a reward function, after you transformed yourself, you transformed your reward function, or even if in some sense you have the same one, you've transformed your interpretation of your reward function in a way that transforms the reward function fundamentally. Like you could have a reward function of pleasing people, and that could persist through your own self-transformation. What you think of as pleasing people when you're 50 may be very different than what you thought of it when you were 20. The fact that it has the same words there, it's still a very different thing. So yeah, enacting this sort of paradox, if you formalize the idea of individuating yourself and of self-transforming in the paraconsistent logic, you can have that contradiction. And as a logic-based AI system, you can try to learn procedures that will achieve rewards. So you want to learn a procedure so that following this procedure implies maximizing individuation. following this procedure implies maximizing self-transcendence, but those implications exist in a paraconsistent logic. So you can be seeking those two contradictory things in a completely valid way. Click. If you look at the time series projection, one thing you would come up with from looking after these two contradictory goals will be an oscillatory pattern where your degree of individuation gets stronger and weaker over time, and your degree of self-transcendence gets stronger and weaker over time, which again this is the sort of cyclical process that we see in natural systems and in humans. And if you project into social systems, you get into resonance type things, right? Where if you and other people in your social group are going through wave dynamics of increasing and decreasing individuation and self-transcendence, and you're synced in with each other while you're doing that, then you have open-ended intelligence at the level of the cultural group based on resonance of the oscillations in the individuals, where the oscillations are coming implicitly from the reasoning activity in the paraconsistent logic system. Click. And you can flesh this out further, as I do in the blog post, and sort of look at, okay, as minds pursue these two paradoxical goals, how continuous will their development actually be? And you can look in cognitive architecture and say, for minds with certain cognitive architectures, they may be more likely to preserve individuation better. Minds with other sorts of cognitive architectures may be more likely to just radically transcend and make a total break from the past. You can basically look at how good is the mind at inference versus how good is the mind at remembering stuff. And after going through a bunch of arguments, you can convince yourself that a mind that's really good at reasoning but forgets a lot of stuff is likely to just keep transforming itself in clever ways over and over again, and it doesn't even care that much about what it used to be before, because its knowledge is sort of dominated by its recent history anyway. And if you are really good at remembering your history, you have a very robust long-term episodic memory, but sort of slow at thinking, that mind is going to have a bias toward retaining individuation over a long period of time. So I think we could develop different AGI systems that balance these things differently. Humans have a certain balance of these things that evolved, right? Click. And yeah, this was the resonance point I made. If you have a multi-agent system, again, part of what you want is for the systems, the multi-agent system, to reinforce both each other's individuation and self-transcendence. And this way of thinking has lessons I don't have time to unravel for human AI interaction, as well as for interaction among multiple different AI agents. And I think again, if you think about human AI interaction in terms of reward maximization, or if you think about the formation of groups of AIs in the shared environment in terms of reward maximization, you end up coming to quite different conclusions on the social psychology level than if you look at in terms of individuation and self-transcendence. And if you go back to, say, Irving Goffman and early pioneers of social psychology, say Goffman's book, The Presentation of Self in Everyday Life, of like how you build up your self model based on the performances you're giving for the others in your other community of performers and audience members, right? I mean, this has to do with how you build yourself in order to give certain performances to others in your environment. And doing that successfully in a peer group is a lot of what humans do when they grow up. And it has to do exactly with this, of learning who you are and how you grow based on others who are building themselves and growing sort of synced in with you, right? And if you can make AGIs that grow up with people in the way that people grow up with their peer group in a successful childhood, this is the sort of way I think that you're going to get AIs that have positive ethical orientation relative to people, rather than trying to bake in like be good to people, make people smile into a reward function. It's just somewhat different way of thinking. Click. So having gone through a bunch of highly abstract stuff, I just want to give very brief view into some of the ways in which I'm trying to cash this stuff out in reality. So we're working on agents of systems in the Minecraft world, and this is like a random snippet that doesn't really show multi-agent interaction, but I don't have time for that. But I think if you have multiple agents trying to carry out activities together in Minecraft or any other shared environment where there's percepts and goals and so forth, I mean, you have these issues come up even there, because I mean the system needs to survive, and it needs to say maintain its house and its little fort and its surroundings, which is a form of individuation into the extended mind of the system and its environment. But the systems, they also need to learn and grow, and they're building new tools, they're creating new structures. And so you have simplified versions of individuation and self-transcendence, even in a world like Minecraft, where you can build things, if you consider the tools and the homes and the structures that the agent has as part of its extended mind. And so you can already explore this sort of collaboration there. I mean, there was some fake news a few years ago about some Facebook AIs that invented their own language, which was complete gibberish. But what we're looking at here is really trying to get AI agents in Minecraft world to invent their own language, to collaborate, to communicate within the world, to collaborate on achieving goals. And I think that comes along with this paraconsistent motivational dynamic I've been talking about. Click. It's the last click. Right? No, you have to click again. Double click, triple click. Well, so this is a Grace robot, one of the sisters of our Sophia robot, and of the Desdemona robot, who will be performing music with us here tomorrow night. So I think these robots are another very interesting way to explore these different phenomena, because they need to really enter into human psychology and human society in all its perversity and all its wonder. So I mean, if you have an elder care robot like Grace, who's supposed to be by the side of someone going through early stage Alzheimer's or something, I mean, again, you can do some very valuable things very simply. You're just combating loneliness. You're helping them place calls with their family and so forth. So there's a lot of good you can do without any AGI or any profound connection with the person. But if you want to take a step further and provide really deep level of, say, end of life care with an intelligent robot, there's nothing deeper into the paraconsistent logic of individuation and self-transcendence, and like someone confronting their own death, right? And people are mostly sitting in a nursing home confronting that by themselves right now, with a visit every week from their family, right? So if they have a robot next to them, keeping them company as they go through all these transitions, I mean, it's a really important opportunity to do good for people. But it's also an amazing opportunity for an AI to encounter some of these very deep aspects of human motivation and psychology. So I think in multi-agent systems and game worlds and humanoid robots that are really engaging with people in the deeper aspects of their lives, these are among the ways we can flesh out these seemingly abstract ideas. And getting back to the initial theme of my introduction to the conference, I mean, I think what's really cool right now is, like, I would have just pontificated about this in a blog post. Like now one of the things on my plate for this fall is to actually code paraconsistent motivational system in the meta language of our new OpenCog Hyperon system. Like we're able to code paraconsistent logic, non-well-founded set theory. We can code these various aspects of symbolic modeling of social psychology in our language interpreter and play with it against our distributed knowledge graph. And we can actually deploy it in humanoid robots that are talking to real people, right? So the ability to make some of these things real due to all the supporting technologies that are coming together now, I think is going to accelerate things tremendously. So I think that wraps up my introductory remarks and my keynote. I want to thank everyone for coming here and listening. I want to thank the sponsors of this conference, Future AI, with their amazing graph-based AGI approach. You can find out about on their website. Springer, which is publishing the proceedings, and then the AGI Society, which Pei Wang, Marcus Hutter, Matt Eclai, and others formed a number of years ago, has been running this AGI conference over the years. And my own company, SingularityNET, has helped sponsor the event. And True AGI, which is a spin-off of SingularityNET that's developing OpenCog Hyperon and SingularityNET systems for practical rollout in the enterprise. And so we've got a bunch of AGI oriented efforts going on here as within the sponsors, as well as among the participants of the event. I also want to put a shout out to the Northwest AI meetup, which you can see a poster for here in the venue, which is mostly online since COVID, although it's organized by Mark Archibald and others here in Seattle area. Most of the meetups are now virtual, so you can log in usually on Sundays, and there's freewheeling discussion and presentations on AGI topics. Also, SingularityNET and True AGI host a AGI discussion forum every couple weeks, which is also online and Zoom. So there's ways to follow up beyond the conference with the Northwest AI meetup and the AGI discussion forum. So thanks for listening, everyone.
Hello, everybody. Welcome to.
Let me take just a couple questions because I ran on a bit as I'm prone to do.
Everyone, I'm sure. And the fact that you're getting up to ask a question. Anyone got a question? Good question. Any questions online come through? Any on YouTube, on Zoom? We've one in the room back here. Let me bring you the mic. You've solved it all. We're radically self-transcending here.
Hi, Ben. Thanks for the great talk. When you talk about individuation and self-transcendence as kind of these two key aspects that you're describing, it seems that Homo sapiens, their transcendence from other animals is the collective culture, the artifacts of society, the creation of knowledge that is like an aspect or a component of the intelligence of our species, which maybe makes us transcend other animal intelligences. So is that, I mean, you touched on the psychology, social psychology, the, multi-agent thing, but is the collective of knowledge or belief systems or those technological aspects or whatever, is this another discrete component?
So where I met Weaver when he was working on his thesis for open-ended intelligence was at the Global Brain Institute at the Free University of Brussels. And the whole theory of open-ended intelligence is designed to apply to systems on multiple scales, right? So you could look at an individual cell as an open-ended intelligence, with in some ways a more limited intelligence than the whole human body. You could certainly look at a company or the totality of humanity as an open-ended intelligence also. And when I gave my sketch of a motivational system, it was pursue individuation and transcendence for yourself and other systems. The other systems may be at multiple scales, right? So that is a very subtle point that's almost hard to think about, though, is like to what extent are these goals being pursued at the individual level? To what extent at like the tribe level or the global brain level? Because like it's all happening at once, coupled together with subtle dependencies among the different levels, right? And for an AGI, it may get even weirder because you could have what I described as a mindplex. We have a society of different minds that can swap brain matter among each other and have like Wi-Fi telepathy among each other. So yeah, I think that the interdependence of the open-ended intelligence on different levels is quite subtle and hard to sort of understand. So I acknowledge the question, not necessarily have an answer, but it's an important area of the question.
All right, so my question is, like, if we want to really like shift global consciousness to recognizing the feasibility of AGI in the next decades or years, and I kind of agree with your timeline, by the way. I think that it's very possible AI could emerge in the next 5 years. But if we want to shift global consciousness, maybe we need to make ways that many more people can play with these things in an exploratory and playful way, especially the young. And so what I want to ask you is, like, how much thought do we give to creating tools like, for example, Scratch is a drag and drop builder for kids to learn programming. But why isn't there a Scratch where those are modules for like cognitive architectures or APIs that, like, why isn't there something like the TensorFlow Playground for AGI, or a single site that compiles like direct access to where you don't have to go, like yesterday with the NARS thing, I had to go to the repo and clone it and compile it, right? But there could be just an API that's available because it's a text in, text out system, right? There could be an effort made to reduce this to like
I have a couple answers to that one. I mean, first of all, I mean, I've taught kids programming using Scratch. It's very cool. I would say both. And I also did robotics hacking in the late 90s when there was no Scratch, right? So I would say both narrow AI like TensorFlow is attuned for, and hobby robotics are just at a more mature phase of development than AGI is. So because they're at a more mature phase of development, I mean, easier to use tools have been created. And I mean, when robotics was an earlier research phase, you didn't have Scratch. And when machine learning was, I mean, I was involved when I was at Waikato University in New Zealand. We created Weka, which was the first open source machine learning toolkit, and it didn't have a tensor board. It wasn't as easy to use as TensorFlow. So part of it is just the reason it's not there is because AGI is at an earlier stage, and these tools will probably come within the next few years because AGI is advancing further. But I think another piece of it, I mean, you talk about NARS. I mean, NARS is being pulled together on a shoestring budget. I mean, look at, you probably used Theano a few years ago, or like I love Theano, deep learning library from Yoshua Bengio's group. It was mothballed in favor of Torch and TensorFlow. Why? Not because the people behind it were less clever. I mean, the people behind Theano just didn't have as much money as Facebook and Google. So they couldn't build a tensor board. They couldn't build the quality of bindings into CUDA and so forth, right? So, I mean, the thing is to make really slick user interfaces, to make things that will install with no problem on every machine and so on. This actually takes Google, Facebook, and so forth a lot of money and highly paid people to make all this work. And NARS doesn't have the money to do that. Frankly, SingularityNET and TrueAGI, we don't have the money to do that either. I mean, we're happy to be funded to pay for some researchers to work on our system. We don't have money to pay like a UX team to build an easy to use interface for people to play with our stuff at this moment. Maybe we will next year, right? So I think it's a combination of those factors, and I think they intersect. Like the money to do all that slick stuff comes when something is at a later level of maturity, right? So that's, now can we somehow shortcut that by building that stuff now so as to help things accelerate quite possibly. I would say it also takes a different skill set. Like the people on our own research team who are best at developing AGI are probably not very good at UX and developing simple to use interfaces. I mean, Scratch took a while to come by. Like I remember Lego Mindstorms was crappier than Scratch. It was easy to use, but it was like awkward and it was hard to do things. So it seemed to take a number of iterations to get to that, to something that was easy to play with, yet not so weak that it got boring really rapidly. So there, I guess, to make easy to use AGI tools would take that same sort of learning curve. But we were discussing this at some level in the Hyperon workshop yesterday, right? Because we have the meta language for Hyperon, which is very powerful, but is accessible only to people who want to deal with like probabilistically, gradually, dependently typed functional languages, which is like a small set of the programming community. You can create DSLs in Meta, so potentially you could make like a Scratch level DSL in Meta, which is like Hyperon for kids, right? They make a drag and drop interface for it there. But who's going to do that? I don't know. Is probably no one on our team at this moment. So. Cool. Yeah, I'd be psyched for that. Yeah.
We've got 5 more questions, I count in the room, 6. We are hosting, True AGI is hosting an online Discord session right now. So one option is to go on there and put all your questions in Discord and we can answer them. Another option is to just do a quick fire on these last 5 questions and shorten lunch.
True, false questions only. Yeah.
True, false questions only. Okay, we're doing
actually just true, false questions only.
True and false, but neither true nor false questions. Who's got neither true nor false rapid fire question? Did you want a rapid fire question?
I'm sorry. I'll try to figure out how to phrase it so you can answer true or false. I think I can do it though. I think that like you could say that you can't find one reward function that makes sense that humans are always maximizing, but there's evolution, and then it's kind of sacrilege to say that evolution has any goal or anything like that. But it's sort of maximizing things that reproduce themselves, right? True or false?
If you use the microphone at the lectern.
Given the sort of, it's true, but that sort of contains a lot of. Okay. I mean, evolution has symbiogenesis. It has all sorts of complex self-organizing dynamics, and it has differential selection based on reproduction. And these aspects all work together, right? So I mean, if you look in all the ranks of Stephen Jay Gould or something, you have a perspective on evolution that maximization of fitness based on differential reproduction is one interesting part of the story, but not necessarily what you would view as the dominant part of the story. The role of genetic drift in populations is far greater than is commonly recognized. So that would my general answer to that would be to look at going beyond the neo-Darwinist synthesis in evolutionary biology, more toward a complex self-organizing systems view of evolving systems. Right? That is a long thing.
You mentioned the researcher whose thesis was defining intelligence, and I guess eventually he threw it out the window and abandoned it because it was so difficult. But he succeeded.
It told you how to build an intelligence that didn't really much computers.
Okay, so
closer to the mic, please.
Started looking at how the brain works instead.
So is there a clear definition today of AGI?
No.
And
false.
Right. And so the question is, if we can't define it, how will we
know it exists when we see it, and we're trying to demonstrate it.
Well, I mean, this was solved by Ed Meese regarding pornography, right? I mean, yeah.
Question I can ask.
I mean, I think that's you could ask it about so many things in human life. I don't know how to define love, but I've known when I had it in my life, right? But defining it, you could go on forever and debate it on and on. So I think you can propose various concrete tests, like the robot college student test I mentioned. If you have an AI that can go to MIT, wander through the halls, sit and do the exams and do everything that the human student does. If you have an AI that can do every human job as well as a human, I mean, there are various practical things you could say that most people would agree constitute human level general intelligence. Then if you have a system that can do all those things and makes a new Nobel Prize worthy discovery every 5 minutes, you'd probably consider it as some level of transhuman general intelligence. So I think you can come up with generally acceptable indicators of general intelligence that are not necessary and sufficient conditions or definitions.
Yeah, I accept that general intelligence systems, and humans included, are not simple reward maximizers. However, they still have some, as you pointed out, some need to survive, and that requires some amount of homeostasis, keeping some parameters within acceptable ranges. However, once you introduce uncertainty into that equation, satisficers become maximizers. And I'm curious how you think, and this is clearly borne out by observing human behavior as well. You know, Jeff Bezos, Elon Musk, these guys are maximizers. Even if their own personal goals are just homeostasis and satisficing. So how do you prevent that in an AGI system with your transcendent goal model?
I don't really think Elon Musk or Jeff Bezos or my goals, or probably yours, are just satisficing and maintaining homeostasis. I mean, if that was the case, you wouldn't have so many suicide bombers either. I mean, I think the, maintaining homeostasis, reward maximization is part of the story. And I mean, and if we go back to Josha Bach's early psi model of motivation, I mean, he one of the nice things there is he, drawing on Dietrich Dorner and other things in cognitive science, he simply didn't have a top level motivation, right? I mean, there's a bunch of different demands that a system has, and it has the urge to fulfill these different demands. The weightings associated with these different demands may shift over the system's life and based on its context. So the basic stuff of maintaining homeostasis is there, but it's there side by side with other stuff, right? And which of these rises to the fore depends on a lot of context-specific factors.
I just wanted to emphasize the uncertainty part. That's all.
It's very uncertain. Yeah.
Well, no, as soon as you have a machine that's trying to maintain stability in an uncertain world, maximizing behavior.
Well, there are some. What is it maximizing?
It's maximizing whatever it needs to maintain stasis.
I don't think that's all that cognitive systems like humans are doing. That's all. I think that's just one piece of the puzzle.
All right.
Yeah. I think I'll make this sort of like a true false question. There's like a theory that consciousness, and we really don't know how to define consciousness yet. It's like still a philosophical question, but that in humans, what we think of consciousness arose as evolution, as like a adaptation technique, to survive in a harsh environment. Given that you were talking about like AGI, with a potential for growth, like, do you think AGI may satisfy some sort of philosophical philosophy of consciousness, or what would you imagine it to be?
I'm a panpsychist. I think everything is conscious. So I think if an AGI has a cognitive architecture vaguely resembling that of humans, my working hypothesis would be it will have a conscious experience vaguely resembling that of humans.
Oh my goodness. Thank you, Ben. Hey, Ben. Forgive me if this might be like overly simplistic of a question, but what you've presented about everything, I mean, intelligence and otherwise, does it, being logically consistent, does it align with your gut about how things are going to go? Obviously, you can't separate Ben from the future of AGI, but like irrespective of what you want to happen, what do you think is going to happen?
Well, I'm the older I've become, the more acutely aware of my own ignorance I've become. So I really don't feel like I know what's going to happen. So if I have to guess what's going to happen, I'm innately optimistic just due to my genetic makeup, I think. And so my mom is very optimistic too. So I'm fairly optimistic we're going to create AGIs that are compassionate and loving to people, and that this will be done by a hybrid architecture combining AI algorithm and concepts from many different paradigms, controlling many different interfaces at one time, all integrating knowledge into one big knowledge graph. I think that there may be a lot of destruction and mayhem in human society over some period of years while humanity adjusts to AGI being there, along with all the other changes going on the planet. But I'm optimistic, and I think the people in this room have the ideas needed to get us there. Things just need to be refined, tested, scaled up, and integrated, and so forth.